Hello everyone, my name is Dave and welcome to the NTDRacing. Today is exciting. It is the payout day for this three-part series so far. For us making a roll cage for this Razor 200 EFI using the Bentech software and also the Dragon A250. Today we actually get to cut the tubes and start welding together the roll cage. But before we do that, let's go ahead and jump back onto the Bentech software. We're going to figure out how we're going to order the cuts. We're going to calibrate our tube bender. We're going to drop this thing into Dragon Cam, start cutting out some tubes, and get ready to weld the roll cage on this Razor 200 EFI. Okay, we're back in the Bentech software. They also call it Dragon CAD. And I am on my other computer, which is part of my Dragon A250. I got a couple more things on here I'll show you, but before we get started, I'm gonna have to calibrate my tube bender. And this is something that I only really have to do because I have a Dragon A250. Without that, you've got to do all these things manually, and it's totally doable. I created an entire truck cutting all these tubes and bending them manually. And I have two videos that show you how I did that. One is how do I cut, notch a straight tube with notches on both sides. And that's one video in the description below. And then two is how do I notch a tube that has bends in it. That's another video, and that's also in the description below. And if you watch those, it'll show you how you can get through it. It takes a little bit more time, but it can be done. But today, we are taking advantage of the Dragon A250. So one of the things that we're going to have to do before we get started is we got to calibrate the Dragon A250 to my my bender, which is a JD Squared Model 32. So to do that, I'm going over to Tools and Die Library, and here's that die that we calibrated on the last video. We basically calibrated it for the correct number of degrees of bending, but now we got to do the rotation as we feed that tube into the machine to make sure that it's bent at the right place in relation to the copes and the other bends that are on there. So what we're going to do is we're going to go over to bend marks, and it's got a rotation wizard, and we're going to start running through this. So there's my tube die we're going to use. We're going to use a Dragon machine, and then the tube we're going to use is 1.5 DOM with a 0.09 wall. There was two in there because I was messing around with one. And then our machine we're using is a JD Squared Model 32. I went and took these dimensions off of my bender, and it ends up coming to 3.125 for that dimension, and then 4 inches for that one. And this tube we're cutting is 224.5 inches because I've already cut some off of it, so it's a slightly shorter tube than normal. And then next, so it gives me some dimensions that's going to go into the machine. And now I'm going to go ahead. It's telling me make sure I home the machine. So I say, okay, I'll do that. And we'll open up the Mach 3. We're going to connect to the machine, and then now we're ready to home it. Let's go through a homing operation. All right, now that we're home, we can close that window out and we can say start. And what's going to happen now is based on the dimensions of the tube that we put in there, it's going to go ahead and move itself to a point where we're ready to load the material in there. So let's load a tube in there. A little bit of setup here as we go ahead and get the water set up and everything like that, but then we'll be ready to start cutting this tube. All right, so here's the tube that we just cut out. It's coped on both ends. It also gives us the number of the bend. It's number 1. It's gonna be 94 degrees. With the spring bit, that should give us 90. And then here is our aligning marks. Let's go ahead and put this thing in there, and I'll show you what I'm gonna do with the aligning marks. All right, just so that I can go with some consistency, what I'm gonna try to do is always try to bisect the line right in half. So you can kind of see this little tip here is I'm going to shoot for having that tip cut the line in half. And then as I kind of come over here, you can also see that it also bisects that line. All right, let me show you how I got this in here. I have the tube clamped to the table like they show in the tutorial. It's 90 degrees perfectly with the table. Now I need to measure this tube and the angle that it makes. It's in here and it kind of rotates. You can kind of see how nicely that thing fits in there once it's seated in there, it's almost a perfect, you can't even get your fingernail inside that cut. All right, and I get 7.6 degrees. We'll go ahead and put that into the calibration wizard. All right, after running a couple times, I came up with 7.8 degrees is what we've got, and we'll hit next, and that looks exactly like what I had. There we go, and there are the die, the start, die limit, and then here's the rotation offset 277.8. And then as I hit finish there, it's going to apply to that die, and then it'll always be in there. And then now all those things are set up and ready to go as far as when I bend the next piece in that same die with that same size tubing. All right, going back to the Dragon CAD or the Bendtech software, now we're actually ready to go ahead and start making the cut paths for all of these tubes. And so we need to kind of have some general rules that we follow when we do this, such that we don't forget kind of what tubes are already there and what, so like for example, when I bring this tube in right here to this tube, is there any other tube there right now? That isn't much of a factor there, but as you kind of come down here and you see this node, as I bring this tube in, what other tubes are already there? You kind of need to know that such that you don't have you don't cope two tubes and you don't have enough material there and you got to cut a whole nother piece. So you need to have some good general rules. And as a general rule, I will generally make this whole B pillar piece right here all at one time on a flat table. So this will all be one piece kind of put together. And then I'll start with all the bent pieces next, and then I'll kind of go with the straight ones. And in general, if I have overlapping tubes, like say these tubes right here, the driver's side tube will always terminate fully on the bar, and then the passenger side tube will always cope to the driver's side tube. That's just a rule I give myself so I don't forget those. So let's kind of just start from the beginning here. First off, the B pillar here, it doesn't have any cope, so there's really no cuts. It's just a tube that the way it is, and the machine will cut that one, and then it'll give me some bends for that. But what I do need to do is I do need to go to cutting. I need to cut this tube right now here, which is kind of the tube that goes across right here first. We'll start with that one because that one will be a solid tube that goes all the way in there, and that one will always be solid. So I'm going to click on new cut, and I'm going to say this tube right here, and then it paints that one green, and that's a tube that I'm cutting. And then now I need to tell it, hey, what tubes are you cutting in relation to? And in this case, we're only cutting in relation to one, and then I'm going to go ahead and complete that cut. And as we kind of scroll in here, you can see the cope that the machine is going to go ahead and cut for that tube. And then now what we need to do is we need to do another new cut. We need to select that same tube right there, and then it's going to cut on the relation to the other side, and then we'll complete that. And then now that it completes all the cuts for tube number 10, and we'll go through and rename that tube to just 10 as opposed to, we'll take the word straight out because we don't want it to write straight on the whole tube as we were writing. We just wanted to write number 10. We get that it's a straight tube. All right, from there, we're going to go ahead and do these other tubes, and you get to see what I'm talking about when it says cut in relation to something. So let's cut the driver's side first, like I said, and we'll start up here at the top. We'll say we're cutting that tube, and we're cutting it in relation to that tube, and that's complete. That's a pretty simple cut, and you see how that one looks. But down here, we're going to start a new cut, and we're cutting this tube. But like I said, remember, this tube is already going to be there, so we need to cut it in relation to that tube, and we need to cut it in relation to that tube. None of the other tubes are going to be there just yet as that one goes in. And as we complete, you can kind of see now how that thing has coped to both of those. Likewise, we go over here, we say make a new cut over here. We're going to cut that tube. It's going to be cut in relation to that one. And then the driver's side one, just kind of following our rules as far as what tubes will already be there. And you see how that cope is going to look. And then the same thing down over here. We're going to cut in relation to that one and that one. Spin around. You want to kind of make sure that you're cutting in relation to the right tube and you haven't picked the wrong one or something like that. And then we'll complete. And now we've kind of completed all of the tubes that make up this B pillar here. And so all of those are done. We can probably tackle the back here while we're back here. We'll say new cut, and we'll say this tube right here, which will probably be, I'm probably going to put that tube in before I put the rest of the tubes in. And just to kind of set the dimensions for the back, and it'll help kind of hold the thing up. So I'm going to go ahead and I'm going to say just cut that in relation to the bend. Boop. That's going to be complete there. And then I'm going to cut the other side
new cut. I'm going to cut this side in relation to that tube, and that'll be complete. And then I'm going to go ahead and cut new cut. Say this cut in relation to, again, the bend. So there, complete. And then new cut, and this one, disregard. I'm going to go ahead and say new cut, this one in relation to there, and complete. There, now we've got all of these cut, all the ones in the back, and we can kind of just start working our way forward. The next ones I would like to work on, probably because what will happen is I'll probably weld, or at least tack weld all these in place, and then we'll probably bring in these A-pillars here. So now what we'll do is we'll go ahead and we'll say new cut, and there's gonna be no cut on this side, but over on this side where this one comes in, I'm gonna say cut that one. And this is one of those cases where, you know, I'm really not really sure which ones it touches. So I'm just going to select all the ones that should be there. So I'm going to cut in relation to that, but I'm also going to cut in relation to that tube just in case it's there. And when I say complete, if you kind of look in there, you might see it does actually indeed probably touches that other tube just a little bit there. So if I didn't select that other tube, then that piece would be in the way when I went to put this thing together and have to grind it off or something like that. Or even worse, you know, if I coped both of those in relation to each other, there'd be no piece there, and then I have to go and cut another tube for that. So I'm going to complete that, and then I'm going to go over and do the same thing on the other side. I'm going to cut this one. It's going to be cut in relation to the bend and that tube, and complete. There, now I have the entire A-pillar done. I can kind of start working myself across now. I'm going to say cut, and just kind of complete doing the same thing. Is all the tubes that are already there, I'm going to select right now. So that tube's going to be there, that one, and that one will be there. And complete that, and then a new cut there, and that tube will be there. All right, we're getting down to the end of this project. I just want to kind of catch you up on some of the changes that I made. I went and changed these to 1-inch DOM right here. So those green tubes, and that's in accordance with the rules as far as the minimum tube length, and I think that'll be okay for those. I also changed the order of how these tubes are cut. I made these green tubes right here terminate completely on that tube, and then I bring this tube right here, this cross tube here, in next. And the reason is I want to be able to weld all the way around that green tube before I bring the blue one in, just to increase the strength. So you really got to kind of consider the weld order and make sure you can get and do welds, you know, as you're kind of going in there, because if I put the blue one in there first and then I drop that green one, the green one would have to be in there before I drop the blue one into weld. So I would basically be missing like half of 180 degrees of that weld. So I didn't want to do that. So just to ensure I had good strength over the B pillar, I changed the order in which those are cut and placed in for the welds. Finally, just kind of, you know, a little bit of paranoia before I start burning through a couple $100 of tubes. I went and QC'd everything that was in there. So what I did is I went through the cutting and I went through each individual cut, walked all the way down and just kind of made sure, okay, am I cutting in relation to the right thing? Does it follow those rules that I had planned on as far as how things are cut and in what order, what things will be there? And then as I was going through that, I had a piece of paper next to me where I wrote the labels for each one of the tubes down so I could reference that later. And then also I can kind of see a checklist. Yes, I've got all the cuts that I expected to get for this thing. I went over to parts then and I relabeled all of the parts that I did want to have cut out. Just I took the word straight out and I labeled them just their individual numbers, just so it limits how much the pen has got to write. And then also I unclicked the parts that I do not want to have transferred over to Dragon CAM. So if I just don't select those, then when I hit transfer, it won't go over to the CAM program. And then before I kind of even go to CAM, I went and got all my tubes ready to go into the Dragon A250. And the way that I prep them is I kind of think I want to have these things all prepared to take paint. So I just basically use a Scotch-Brite and some Dawn soap and water to wash all of the tubes off. And another benefit of that is as it goes through the Dragon A250, and the Dragon marks it with a Sharpie pen, then since it's not oily, it takes that pen really well, and then those marks will be there later on. They won't wipe off as I go to bend them, and I go to just identify which tubes go where, and they'll still have their numbers on there, which is totally critical when you have, like, say, 100 different tubes, that you don't lose the numbering on your tubes. So now this thing is ready to go over to the Dragon Cam. If I stay in the parts window and I go over to this transfer, and I can basically move one tube at a time, just the way the program works. If I go to any of the other windows, like say, for example, cutting, and I go to transfer, and it's like Dragon Cam, and then now it's going to take all of these from the Dragon CAD computer aided design to the Dragon Cam computer aided manufacturing program, and it's going to basically make a nest of all of those tubes. And what's really cool here as I open it up is that it is going to make two separate nests. So this first one over here, you can see, are all the 1.5 inch tubes. I'm going to click on new nest, and it's going to open up a window where it's going to put all of those, make a list of all those parts. And it's going to open a second window here, which is all of the 1 inch parts. I'm going to say new nest, and now it's going to let me make all those tubes. We'll go ahead and just for this video, we're going to go ahead and start with the 1.5 inch tubes, and I'll kind of show you how I run through that. So as I go through this setup, what I need to do is I need to tell it, hey, what am I cutting these things from? So I actually have tubes that are over 270 inches long. My Dragon A250 is only set up to take tubes that are 250 inches long. So I need to put in 250, and I've got 2 of those tubes that I'll be using. And then the rest of them will fit on the scrap piece of tube I have, which is 189.5 inches left. And that's what I have as far as those go. All the parts are listed in here. I could drag and drop and put all those parts in individually on these tubes. But what I want to do is just let the computer do it. I'll hit auto nest, and then there it puts all the tubes and fits them on there. And if for some reason you have more tubes than you got stock, it's going to tell you you don't have enough stock, to fit them all on there. In this case, we do, and you can kind of see we have some extras on the end over there. If you want to try to also save some of the extra stock on the end there, other things that you can do is if you go back to parts, you can kind of see it opens up this window down here. And let's say, for example, I wanted to save some material right in this zone right here. I can go ahead and move these parts. I can just say, let me try to line those cuts up, and then I can move this part and get it closer. And now you can see maybe I just saved myself 1/2 inch. And at the end of the day, if I do that 10 times or something like that, I've saved maybe enough stock for another project down the road, as I kind of keep some these tubes as scrap tubes or something like that. So I find that there is value maybe taking a couple seconds here to go through these and just orient them and maybe move them, just so you can save yourself some material. And ultimately, we're all trying to save some money because it does add up. All right, once we've done all that, we're happy with how the tubes are laid out on here. Now we're just ready to go ahead and send this over to the Dragon A250. We'll go ahead and hit Run Project. At this point, it's going to go ahead and send all of the information over to the Dragon A250. We'll activate the machine, and let's go ahead and get ready to cut these tubes after running a little homing process again. As I'm cutting these out, I kind of recall back to when I was building Honcho, and I was thinking if I could build like maybe 2 to 4 tubes a day, I'd map it out to about a couple months where I'd have the whole thing done. And I just contrast that with what I'm doing now, where I can almost not get back to the machine to grab the next tube out, as it just keeps spitting out perfectly cut tubes. The Dragon A250 is a game changer when it comes to being able to rapidly produce accurate cuts. All right, I'm totally happy with the cut results. I think it looks really good. There is some dross inside here. Now that can be alleviated by, doing stuff like changing the amperage and speed and that kind of stuff. And what I will do is increase the speed of the cut. It went from an 80 inches per minute to a 90. It reduced the dross a little bit, but it can be better. Besides that, they're all numbered and ready to go. I have to admit to an error that I made, and it kind of revealed itself on this first tube here that I got to go and bend and put into the bender, is when I measured the spring back on an earlier tube, I measured the wrong side. So when I should have put in a value of 89, I put in a value of 91. So it totally messed back the spring back value. So when I do this one, I'll be bending it to 92, and I'll have to recalculate all the spring back values for like the 10 bends I have to do. Not that big a deal, but that'll be a fix in the future, and just maybe some warning not to do that yourself. All right, let's take a look at what we got going on for this first tube bend that we're going to do. It's all lined up in the tube bender just like we did before. Tightened down, ready to go. Some of the things I did is I did make sure that the machine or the bender was level in the forward and aft and also the left and right. I used some of those scissor jacks down there just because those tires are coming apart. And then, or those wheels are, and then I also leveled the tube as it's getting fed into the machine just to try to eliminate any kind of errors that might happen. One more thing I'm gonna do is I'm gonna use this angle cube clamped in here. I'm gonna zero it out. I'll do the first bend. As it pulls it in there, it'll bend, and then I'll make sure that it's zero again before I do the second bend to make sure that both the bends are in plane with each other perfectly. Realize the X on there should do that. I'm just gonna go ahead and have a little bit more fidelity with that, going down to the hundredths of a degree to make that happen. Anyway, let's go ahead and make this first bend. Yes! All right, let me show you what I'm yesing about. This thing dropped right into place perfectly. So that's a huge win. Nice job, JD Squared. Nice job, Pentec. All right, we finally get to start welding this thing together. I'm gonna start with the B pillar on my flat table just to give me the best chance to make that thing perfect. And then once I get that onto the chassis and start putting in the other tubes, it is amazing that the other tubes basically become their own jig and just snap into place, and everything, the dimensions are absolutely perfect with no gaps, which makes it easy to weld. I'm using a Dynasty Miller Dynasty welder. I could use my Vulcan Omni Pro, but since my little boy's gonna be in this, I wanna use the welder that I've got thousands of hours of experience with doing some TIG welding. Okay, while I'm tacking this thing together, I wanted to take a quick pause to kind of show you, this is what Bendtech does for you. Look at that. You really can't even stick your fingernail in there. That is gonna be a nice and easy weld. And that is like on both sides. This is like maybe the 13, 14 tube I put in. And so after all these tubes have gone in, this one still snaps in with a perfect fit all the way around. So let's keep welding this thing up. I think it's looking amazing. So as I'm finishing this thing up, I got to remember that I started cutting these tubes in the morning, and I will do the finish welds before the end of the night. It makes me super excited to get to work on our Bug Dung Beetle, on our 24 Hours of Lemons car, and then the car that I'm calling Honcho 3. All right, I love the results of this roll cage. I think it looks great. I also think it's going to be durable for racing and those kinds of things, a lot more safe than the original roll cage. And just the tolerances that we got from the Bendtech software, and then also the Dragon Cam and the Dragon A250 were so tight. It made some of these really complex welded nodes really easy to do. So I get it, I'm pretty lucky. I have some really cool hardware in my shop to do stuff like this, but I think that it can be done manually. And I show you in some of my videos on how you can cut tubes and do all those things with angle grinders. So how much would that cost? If you had some basic tools in your shop and you want to get something like this, what do you need to add? Let's go ahead and take a look at that and see how much it will cost you to build a roll cage just like this. Okay, so let's imagine one of my friends came up to me and said, hey dude, I want to build one of these things. I've got basic tools. I've got an angle grinder. I got those other things. I got a lot of motivation. I want to build the stuff that you build. What would I get? And this is where I would send you. I'd say first, let's go ahead to Bendtech and get this software, $295. Literally, you can do so much with it that you cannot do with a tube notcher and those kinds of things. Just an angle grinder, a printer, and this software, and you are making some amazing roll cages pretty quickly. And I kind of showed you how to do that in the last 3 videos. Next, you need to have a tube bender as a fabricator. I use the JD Squared Model 32. You can find it here for about $427. You could probably also find it on Facebook Marketplace and save yourself some money, because you also have to buy the dies. And I always buy the 180-degree dies, not the 90-degree ones, just because in future projects I might want to bend further than 90 degrees. So I always buy the 180 dies. And then finally, you need to be able to weld this. Most welding organizations or most racing organizations do not want you to MIG weld the cages. And I've seen some just terrible MIG welds. I know there's some people that are just really good at MIG welding. I'm not one of them. And so I do all TIG welding, and I am a big fan of the Vulcan line of products from Harbor Freight. I have their Omni Pro 220. I use it for MIG welding. I use it sometimes for TIG welding also. I think a dedicated Pro TIG 205 machine is probably a really good way to go because it gives you all the things that you're going to need besides an argon bottle to start welding right out of the box with this thing. And this one is going to have the ability to weld all the way up to 1/4-inch plate steel. So a really cool machine right there. So what does that, get you? At the end of the day, it's going to cost you about $2,400 if you need to get all those things to add to your shop that, assuming again you have all basic tools. I didn't add in tax into this. I also didn't add in shipping, so that'll be a little bit more. But when you consider that one of these roll cages that you get for a razor, and just the small one, the Razor 200 EFI, that isn't even complete with all the things that you are going to need to comply with race regulations, is going to cost you about $2,000 to get that thing to your shop. So it's almost the same amount of money. And when you're done with this, all you really use is the DOM for the build, but you still have a TIG welder, you still have a bender, you still got the program, and you can build more cages. You can change them. You could even get into mass production if you want to do something like that. I just think that this is the way to go, especially if you have the motivation to build it yourself.
I'm really excited about the outcome of this project, not only because I think that it looks amazing, it's going to be a lot safer than the old roll cage, but it kind of proved out those things that I was doing where I was doing the dimensioning, designing in CAD, cutting with the Dragon A250, and I found that all those things were easy and are repeatable as well. I think I'm at the point now where I can go from just maybe concept to having a final roll cage in about 2 days now using all these tools. I think that Bentech also does a great job of designing a product that is versatile all the way from the budget builder to the company that's trying to mass produce products like this. Anyway, a lot of really cool stuff coming up as we make a bunch of other roll cages for other vehicles we have, and hopefully the content, you find it interesting and we have earned your subscribe today. We'll see you next week. Take care of yourself.